Good morning to everyone. Myself T. Muthukumar, Assistant Professor, Department of Electrical and Electronics Engineering, Pongonodu College of Engineering and Technology. Today, I am going to deliver a lecture on classifications of systems in discrete time signal processing subject. So before that, I'm going to give some introduction about what is meant by signal, what is meant by signal processing, and then I'm going for the classifications of signals. So signal is defined as a single valued function of one or more independent variables which contain some information. So it's a single valued function which contains one or more independent variables. Also, it carries some information. And also, it is a physical quantity that varies with time, space, or any other independent variables. It also represented by in time domain or frequency domain. Signal can be function of one or more independent variable, already said that. So that parameters are time, temperature, position, pressure, distance, etc. These are the independent variables that depends upon the signal. So if a signal depends only one independent variable, means that signal is called one-dimensional signal. So if a signal depends on two independent variables, means that is called two-dimensional signal. So from that, signal is a physical quantity and also single valued function. It carries one or more independent variables which contains some information. So next, I'm going for the system. So system is defined as set of elements or fundamental blocks which are connected together to produce an output in response to one input. So it is a combination of the elements or fundamental blocks connected together to produce any output with respect to the input signal. So this is called system. So it has cause and effect relationship between two or more signals. So generally we are representing input is S of n, output is V of n. So output is depends upon the input. So system may be single input, single output system or multiple input, multi output system. So signal processing. So it is a method of extracting the information from the signal, which in turn depends on the type of signal and nature of the information it carries. So it is used to extract the information from the signals. So we are representing the signal in mathematical form in the signal processing and extracting information by carrying out the algorithmic operations on the signals. So we are representing as a mathematical and information extraction can be carried out with the help of algorithmic operations on the signals. So compared to the analog signal processing, digital signal processing have some advantages. Thus, digital circuit do not depend on precise values of digital signals for their operations. It does not depend on precise values. Digital circuit are less sensitive to changes in component values. They are less sensitive to changes in component values. They are also less sensitive to variation in temperature, aging, and other external parameters. So, compared to analog signal processing, digital processing is better. So this is the basic block diagram of digital signal processing. So here, so analog input is given to the A to D converter, that is analog to digital converter. So analog to digital converter converts the input analog signal into digital signal. That digital signal is given to the digital signal processor. So in that, so we are manipulating the signal or processing the signal based on our requirement. So output of this DSP is a digital output. So again, we are using the D2A converter to convert the analog signal from the digital, the output from the digital signal processors. So finally, so we are getting the analog input original signals. Your analog to digital converter and the digital to analog converter is a important parts of the digital signal processing. So discrete time signal. So generally two types of signals are there. One is continuous time signal, other one is discrete time signals. So these discrete time signals defined only a discrete instant of time. So at a particular instant of time only, it will be described. So it is called discrete time signals. So we are representing as x of n is a discrete time signal. So here n is the time, it is independent variable. So there are four ways of representing the discrete time signals are there. So one is graphical representation. So another one is a functional representation. Third one is a tabular representation. Fourth one is sequence representation. So next one is discrete time systems. So continuous time system means which transforms the continuous time signal input signals into continuous time output signal. So it produces the continuous output from the continuous input signal. So it is called continuous time system. Similarly, discrete time system means it produces the discrete time output signals from the discrete input signals. For example, microprocessor, semiconductor memories, shift registers, etc. are discrete time systems. So this is a block diagram. So here input is x of n, output is y of n. So y of n is equal to transfer function of x of n. This is the output of the discrete time system. So the classification of discrete time systems. So based on the conditions, so it is classified as static or memoryless system or dynamic or memory system, casual and non-casual system, linear and non-linear system, time invariant and time varying system, stable and unstable system, invertible and non-invertible systems. So static system. So a system is said to be static or memoryless system if the response is due to present input alone. So that is the output is due to the present input alone. So it does not dependent on the past or future values of input or past values of output. So output is only depends upon the present input. It is called static system. It does not depend on the past and future values of input and also past values of output. So it is called static system and also known as memoryless system. The example for static system is y of n is equal to x of n. Here input n is time domain, n input is depends upon n, output also depends upon n. Output is purely depends upon the input, present input only. So next example is y of n equal to 2 into x square of n. So next one is a dynamic system. The system is said to be dynamic or memory system if the response depends upon past or future inputs or past output. So it depends upon the past value and the future values of inputs and also past value of outputs. So example is y of n is equal to x of 2n. So y of n equal to x of n plus x of n minus 2. Y of n plus 4 into y of n minus 1 plus 4 y of n minus 2 equal to x of n. So for the above conditions, the output is depends upon the past and the future values of the input and the past values of the output. So the system is called dynamic system. So a pure resistive electric circuit is a static system. So we are taking the pure resistance circuit means that is based on static system. So whereas an electric circuit having inductor or capacitor is a dynamic system. So the circuit which consists of inductor and the capacitor means that is called dynamic system. Purely resistive circuit means that is a static system. Casual system. So a system is said to be casual or non-anticipative if the output of the system at any instant n depends only on the present and the past value of the input. So output is depends upon the present and the past values of the input, but not on the future input. So only it depends upon present and past value of input, not depend on the future input. So generally it is called real-time systems. They are physically realizable. So impulse response of casual system is 0 for n less than 0. So h of n is equal to 0 for n less than 0. So examples of casual systems are y of n equal to n into x of n. Y of n is equal to x into n minus 2 plus x into n minus 1 plus x of n. So this is an example for casual system. Casual system means output is depends on the percent and the past values of input, not dependent on the future input. Non-casual system. So that is anticipative system. So if the output of the system at any instant n depends on future inputs only. So output is depends upon future input. So it is called non-casual system. So they are not physically realizable. So they are not a real-time system. So a delay element is a casual system, whereas image processing system is a non-casual system. So example for non-casual system, y of n is equal to x of n plus x of 2n. So x of 2n is the future input. So output is dependent on the future input. So y of n is equal to x of 2n plus 2 into x of n plus 2. Linear and non-linear system. The system which obeys the principle of superposition and the principle of homogeneity is called linear system. So it should obey the principle of superposition and the principle of homogeneity. So it is called linear system. So it does not obey the superposition theorem and the homogeneity system means that is called non-linear system. So superposition property means which produces an output y1 of n for an input x1 of n and output y2 of n for an input x2 of n must produce an output y1 of n plus y2 of n for an input x1 of n plus x2 of n. So this is a exponential function, that is a mathematical function capital T, that is transfer function of a into x1 of n plus b into x2 of n is equal to a into transfer function of x1 of n plus b into transfer function of x of 2. So if it obeys this condition means the system is said to be linear. Otherwise, the system is a non-linear system. The examples for the linear system are filters, communications in channels are the linear system examples. Next one is time invariant and shift invariant system. Time invariant and shift invariant or shift varying or time varying systems. So time variance is a property of the system which makes the behavior of the system independent of the time. So output of the system independent of the time, that is behavior of the system is independent of the time means that is called time invariant system or shift invariant system. It means the behavior of the system does not depend on time at which input is supplied. So invariant property is called shift invariance. Time invariance also called as shift invariance. The system is said to be shift invariance if its input and output characteristics do not change with respect to time. For mathematically, if a transfer function of x of n is equal to y of n, then transfer x of n minus k equal to y of n minus k. So a system not satisfying the above requirement is called time varying system or shift varying system. T of x of n minus k equal to y of n minus k, the system is not satisfying this above equation means that is called time varying system or shift varying system. So example for fixed system also, it is also called a fixed system. So the condition y of n minus k not equal to y of n minus k, if the delayed output is not equal to the output due to the delayed input, then the system is time variant. So output is not equal to the delayed input is called time invariant. If all the coefficients of the difference equations are constant, the system is time invariant. So for example, in this equation, so all the coefficient of the difference equation will be constant, so it's called time invariant system. If even one of the coefficients is function of time, then the system is time invariant. So here, so y of n minus 2n, y of n minus 1, here n is with respect to the time. So this system will be dependent on the time function, that is coefficient is a function of time, then system is called time variant system. So systems satisfying both linearity and time invariant conditions are called linear time invariant system, that is called LTI system. Next one is stable and unstable system. A system is said to be stable, that is bounded input and bounded output. Stable system means every bounded input produces a bounded output. So this is called BIBO stable. So output of the system does not diverge or does not grow unreasonably large. So this is the example of BI. This is the characteristic of BIBO system. So if the output is also bounded, then the system BIBO is stable. Otherwise, the system is unstable. Bounded input should provide the bounded outputs. So that is called BIBO system. That is a stable system. It is not happening. That is called unstable system. So next one is recursive and the non-recursive system. So a system whose output y of n at a time n depends on any number of past output values as well as present and past input, all recursive system. So output of the system depends upon past output values as well as present and past input is called recursive system. The example are y of n minus 1, y of n minus 2, y of n minus 3. So these are the past output. So example is function of y of n minus 1, y of n minus 2, y of n minus n, comma x of n minus 1 and so on x of n minus m. So example of recursive system is a IAR system. IAR filters of the recursive system. The system whose output does not depend on past output but depend only on present and past input is called recursive, non-recursive system. So it does not depend on past output but depend only on present and past input is called a non-recursive system. So FAR system or non-recursive system. So that's all about my presentation. So from that lecture, so we have some idea about what is meant by signal, block diagram of signal processing, and classifications of signals. Okay, thank you.